Basically, I'm given the task of introducing you to some community medicine MCQs and to discuss how these questions are asked in the exams. So what I did is actually I prepared some questions of my own, also took some questions from the previously asked questions available on the internet and asked for various exams. And I have included easy questions also, medium questions also, and difficult questions also. So difficult questions I have put at the end. So difficult questions, I have detailed explanations for that also. So that will take some time to deal with. So easy questions, I think we can go past the easy questions in a quick way. If you are having trouble with understanding the easy questions, then I am ready to explain every question. Okay. And if you have enough time, I'm also willing to take other sessions if it is required. Okay. So don't worry. If you have any doubts, you can contact me anytime. I can share my number also with you, and you can just WhatsApp me. And I'm also an executive member of IMA, so I'm available with IMA all the time. Okay, so to start with, just move on to the first question, and we will see. Okay, so the data which have already been collected by someone is called dash data. Secondary, primary, array, or quantitative data. So do you have any idea about this question, or have you been exposed to the types of data? I got answers like secondary. Yes, everyone is answering secondary. Fine. So you are right. The answer is secondary. So what you have to keep in mind is when the data is collected by someone else for some other purpose, that is the most important point. The data is collected for some other purpose than your study, then the data is a secondary data. But keep in mind, if you are the main chief investigative officer or say the primary investigator of a research and you are employing people to collect data for you, then such data, even if collected by someone else, is not secondary data, but your primary data. So the point is for what purpose this data is being collected. Okay, so the key word in this question, in every MCQ, I always suggest students to read each and every word carefully before you answer. So if in this word, in this MCQ, the key word is already. That is, if it is a primary data, if they are referring to data being collected by someone else, the word already will not be there. The word already means it was already been collected even before the study or even before the primary investigator has got hold of the data. So that is why the answer is clearly A. So always pay attention to every single word in the MCQ. Okay. So moving on to the next question. Yes. When all the values in a series occur the same number of times, then one must not compute the. Yes. Yes, has started getting answers. Somebody's answered mode. Yes. C. Any other answers? No, I'm getting all the answers as mode. So it is, you are right. The answer is mode because mode is the frequency of the largest repeating measure. So if we are saying the percentages of each and every symptoms that come to your OP, if fever, you have say 500 patients, 350 with fever, 100 with cough and all. If that is the data, then if somebody is asking you what is the mode, you can say that, okay, the highest frequency has been for fever. So fever is the answer. So that way also a mode can be used. That is one usage which we often overlook. So in a distribution, is the frequency of, is the category which has the maximum frequency. So all the values, the same values, see within one variable, if you are applying this mode, usually we use mode, the mean, mode, and median as measures of central tendency in a quantitative variable. So that is the simplest usage. In that simplest usage, if you are having a data, say if you are taking the hemoglobin values of 100 people, what is that particular value in which you get the maximum number of people. That is, if 25 people have a hemoglobin value of 11.2, and if that is the highest frequency, then that is the mode. Okay, I think that is clear. So these are all simple questions. I'm happy that I'm getting the right answers from almost all the candidates. Third question, a distribution of 10, 20, 30, 40, 50, the mean is 30. The sum of deviations from mean will be. Okay, so this might be a bit difficult for those who don't remember all these things. So I'll just tell you that when you have a variable, the first thing you want to check is whether that variable is qualitative or quantitative. If it is a qualitative variable, like say gender, then we express it as percentages. Fine. If it is a quantitative variable, we need two values, or say we need two measurements to depict that variable. That is, say if it is height or if it is weight, we want the mean, that is the average, and also we want the standard deviation, that is the measure of dispersion. The standard deviation is actually your root mean square deviation. That is, you find out the mean, then you find out the mean deviations, then you square it, then you take the root. That is your standard deviation. Here, the question is distribution of 10, 20, 30, 40, 50. The mean is 30. Sum of deviations from the mean will be. I got some answers. Yes, you are right. The answer is 0. Because when you just take the mean deviation, the mean is 30. Then 10 will give you a mean deviation of minus 20. 20 will give you a mean deviation of minus 10. Like that, 40 and 50 will give you plus 10 and plus 20. If you add everything up, minus and plus will cancel each other, you will get a 0. I'm going a bit fast because I assume that you already know these basic things. If somebody has a doubt, they can tell me in the chat window to explain once more. Okay. This question is a bit tough. The sum of squares of deviations of the values is least. That is, sum of squares of deviations of the values is least when deviations are taken from. Okay, one student has asked me to explain the previous one again. So basically, mean is the average value. So you all know that 10, 20, 30, 40, and 50, the mean value is 30. There is no doubt in that, right? So it's already given in the question. That is, the mean is 30. Then they have asked the sum of deviations from the mean. So you have to actually first find out what is the deviation of each value from the mean. The mean is often denoted by x bar, that is x and a line above it, and every value is denoted by x1, x2, x3, x4, x5, like that. So for x1, that is 10, we find out the mean deviation as x1 minus x bar. Like that, x2 minus x bar, x3 minus x bar, x4 minus x bar, x5 minus x bar. That is how we calculate the deviation of each of these values. Then they have asked us to find the sum of the deviations. So it is, say, first value is 10, that is their x1. We find out what is the deviation of the first value. It is x1 minus x bar, that is 10 minus 30. It will give you minus 20. So that is your mean deviation 1. You can call it, say, D1. So what is D2? Is 20 minus 30. That is minus 10. D3 is 30 minus 30, 0. D4 is 40 minus 30, 10. And D5 is 50 minus 30, is 20. Now when you add everything up, you get minus 20 plus minus 10 plus 0 plus 10 plus 20. Right. It will add up to 0. Yes, Roshni, is it clear now? AN206. Okay, fine. So this is the initial step for standard deviation. To find out standard deviation, what we do is, because this mean deviation when we add like this, so what is the purpose of this mean deviation? The main purpose of finding out mean deviation is to find out your dispersion. How much every variable is distant from the mean. Fine. So I already told you we want a mean value and a standard deviation value to explain a quantitative variable. So mean we have. So to reach standard deviation, I'm telling you how we reach there. So first, easiest way to calculate how much every value is deviating from the mean is to find out the mean deviation. Even before that, the simplest one is range. What is the first value? What is the last value? So when you take range as a measure of dispersion, the problem is range does not represent every value in the list. It only represents the first value and the last value. So we want something which actually gives us the dispersion of every single value in the data list. So the easiest one we reached is mean deviation. But mean deviation has this problem. That is the negative and the positive will get cancelled each other. So what is the easiest way to overcome that? Can anyone type me? How can you overcome the issue with the negative sign and the positive sign and mean deviation? Yes, squaring. Exactly. When we square, it is the easiest method. When we square, the positive and the negative will get cancelled, and you get a whole number. That is, even if you square -2 or +2, the answer is 4. So we are actually getting the quantification of dispersion in square times, irrespective of the direction of dispersion, whether positive or negative. So we want how much it is dispersed. If it is dispersed to the positive or the negative side, doesn't matter. We only want to know how much data is dispersed. So by squaring, we can overcome that problem. But squaring creates yet another problem. That is here, say if 10, 20, 30, 40 and 50 are the marks obtained by students in an exam, the mean is 30 marks. When we actually square the standard deviation, the unit of that will become mark square. So the mean will be in one unit and the standard deviation will be in another unit. How do we overcome that? Yes, anyone? Yes, take the square root. As easy as that. So first we take the mean deviation, then we square it, we get the mean square deviation, then we take the root, we get the root mean square deviation. So standard deviation is nothing but your root mean square deviation. This is also another MCQ. Standard deviation is, and they will ask you square mean deviation, root mean square deviation, root mean deviation and all. So the answer is root mean square deviation. Remember it as RMS deviation. So this is how we reach standard deviation. Deviation is as simple as this. Okay. So we'll move on to the next question. The sum of squares of deviations of the values is least when deviations are taken from. This is a bit tough. I won't be worried even if you don't answer this question. But if you answer this question, really good. Yes, I got one answer. Yes, okay, somebody is answering some other answers. I'll give you some time to think on this, to recollect everything that I have told you till now. Yes, somebody is answering mode and some are answering mean. Okay, is there any other answer? Just completion sake. Yeah, I wanted someone to ask this question. Why is harmonic mean in the choice? Okay, is harmonic mean same as arithmetic mean? So one purpose of this question was to also discuss about harmonic mean. Okay, so basically One important point that I wanted to tell you is never get carried away by some choices in the answer. Okay. There might be so many choices which will distract you. That's all called distractors. Okay. So just remember that mean is the most sensitive of all these things. When a distribution is normal or when it gets skewed and all, it's always the mean that is very much, say, flexible or say sensitive. A positively skewed distribution will drag the mean towards the tail, that is the positive side, and a negatively skewed distribution will drag the mean towards the negative tail or the negative end of the table. So because of that, when you take the deviations and square of the deviations, the least numbers will be from the mean, because mean actually is very sensitive to every value in that table or say in that data list. So answer is actually mean, and harmonic mean is there as a distractor. What is harmonic mean? You have another mean also called geometric mean. So these are the three means that you have to keep in mind. One is arithmetic mean, that is the mean that we are talking about right now. Another one is geometric mean, another one is harmonic mean. Geometric mean, we have that in another question. Harmonic mean is actually calculated by, say, if you have 5 values, the A, B, C, D, E, we first take 1 by A, 1 by B, 1 by C, 1 by D, and 1 by E. There are, we have 5 values, n equal to 5, and harmonic mean is given by the formula n by 1 by A plus 1 by B plus 1 by C plus 1 by D plus 1 by E. I'm not having a slide for that because it is not that important. I just want you to know what harmonic mean is. And even if it is there in the choice, if you are okay, if you are sure or almost sure with your answer as mean or any other answer as a median or might be the answer, because you might not be asked about harmonic mean directly in an MCQ. They can ask, but in that case, just you will have something called the reciprocal average or reciprocal and all. If that word is there, harmonic mean will be the answer, because harmonic mean is calculated by taking the reciprocals of all the values in the data. Okay. Fifth question. In a frequency distribution, the last cumulative frequency is 300. Median shall lie in, or the median is the value of which height? They're all simple questions. We'll start to get a bit tough only after we cross the 10th question. After 20, we might need time. Total, I think there are 32 questions. Okay, we're answering D. Everyone is clear on that, right? The question, the problem with the question is there is a word called cumulative frequency. So what is this cumulative frequency? Cumulative frequency is the sum of the individual frequencies. That is, when you have a group data, the number of observations in that group is called by the word frequency, denoted by F, and cumulative frequency is your CF. Okay, so the sample size is always represented by the word N. So in this case, if it's a group data, all the F's or the frequencies will add to N. And when you add all the frequencies, you get the cumulative frequency. Cumulative frequency will be same to number of observations in your data. So if you have 300 observations, a median is the 150th observation. So to be actually specifically clear, if there are odd numbers, the median is given by n plus 1 by 2th term. If there are actually 299 numbers, then we take the median as 299 plus 1, that is 300 by 150th item. In this question, don't have a 151th item or 149th item in the choice. So we can easily go with the most appropriate answer, that is 150. Okay, if they're telling you there are 300 items, then actually they say, for simplifying it, just think you have 5 items. You have 5 items, then the third item is lying exactly in the middle. It has got 2 items in front of it and 2 items behind it. That is the center. If you have 6 items, then now you have 2 items in the center. Right. So if your variable is having six values, then if I ask you for the mid value, you have 2 values. That is 3 and 4. Is that clear? You have 6 values, 1, 2, 3, 4, 5, 6. The 2 middle values are third value and the fourth. Always remember, this third value and the fourth value means it is not 3 and 4, but the value of the variable in the third position and the fourth position. For simplification, I am taking the actual values as 1, 2, 3, 4, 5, 6 in this case. Your values are, say, 61, 62, 63, 64, 65. Then if I ask you for the median, it is the mid value, that is 63. If there are, say, 6 values, that is 61 to 66, then the mid values are 63 and 64. So if there are even number of observations, then the median is given by the average of the middle 2 terms. Okay, that is n by 2 term and n by 2 plus 1th term. That is, if there are 6 items, the third term, that is n by 2 is 3, third term, and n by 2 plus 1, that is 3 plus 1 of fourth term, that is 3 plus 4, the value of the variables in the third position and the fourth position by 2. So if the data is 1, 2, 3, 4, 5, 6, it is 3 plus 4 by 2, that is 3.5. So data is 61 to 66, then it is 63 plus 64 by 2, that is 63.5. Fine. And always remember, whenever we are talking about a median, always arrange the data in ascending or descending order. Only if the data is having an order, we can calculate a median. And for that reason, median is also called your positional average. That is also another MCQ. Is it clear? Okay. Okay. This is a question you need to put your brains. Nothing to recollect and calculate, basically. The price of a commodity remains at rupees 20 per kg for the whole month, then measure of dispersion will be. Rupees 20, rupees 02, rupees 0, and rupees 1. Yes, everybody is answering 0. You are right. There are no wrong answers at all. So measure of dispersion is how much the data is dispersed, because the value remains a constant. If you take a set of values for all the 30 days of the month, all the values will be the same, that is 20, 20, 20. Mean will also be 20, or any other measure of dispersion will be 0, because every value is 20. So if you take the deviation of any value, it will be 20 minus 20, that is 0. And if you do squaring or division or anything on 0, it will again be 0. Fine. Now, weight of the earth is discrete variable, qualitative variable, quantitative variable, difficult to tell. Yes. Okay. So this is something I should explain. Many people are answering discrete. Any other answer? Quantitative. Mekha Murali has answered quantitative. Yes. So anyone wants to be totally practical and say difficult to tell? Okay, AR149 is also going with quantitative. The answer is saying it's quantitative. Okay, and somebody is answering D. Okay, so the answer is C, quantitative variable. Why? Because, so we'll go to type. We have the qualitative and the quantitative. Already told you, qualitative is your gender, color, say eye color, hair color, such variables, where you have only attributes that tell you about the nature of something, but nothing to measure. It is, there is no quantity per se to measure. A quantitative variable is something that can be measured. So even that has been also asked as an MCQ once. You might get some such very simple questions also. So pay very much attention to each and every word in the question. Never get such questions wrong. Okay. Because you can easily make it right by just looking at it one more time. Say quantitative variable, you have two types, continuous and discrete. What is the difference? A continuous variable has a, say, can take any value. It can be a decimal, it can be a fraction, or it can take any value between any two values also. That is your height, your weight, and every variable like that is a continuous variable. Because say if you have someone whose weight is say 60 kilos, if you have a very sensitive instrument, you can easily measure 60.1, 60.2, 60.3 and all. If you have a very, very sensitive measure, you can even measure 60.34565. So this only, the question is how sophisticated you want the instrument to be. The basic nature or the true nature of that variable is continuous. If you want only whole numbers, you can devise an electronic measuring device which only gives you whole numbers. Discrete variable is a variable which does not have this property, but it can only take some whole numbers as its value. Between given two values, it cannot take any other value. Always the example I use is number of children. A woman can have only 2 children, 1 child, or say 3 children. Nobody in this world can have 2.75 children or 1.65 children. So it can either be 1 or 2. That is a discrete value. So weight of the earth can actually be expressed in decimals also if you want to measure it in that way. That is why it is a quantitative variable. If there was a choice, if the choice D was a continuous variable, that would have been the answer. That is, even if a quantitative variable was there in the choice, among the choices, if it continuous variable was also there, that would have been the choice. Because you're always asked to write the most appropriate answer. Is it clear? Okay. So we move on to the 8th question. The relative frequency distribution presents frequencies in terms of dash. This is a bit difficult. If you haven't seen a relative frequency distribution, it's a bit difficult, but you can have your idea on this. If you see in a table, you will not forget. A relative frequency distribution is a distribution where you actually find out the relative frequencies among the whole frequency. That is, if the total frequency is say 20, and if the first item has got a frequency of 3, then we do that is a relative frequency of that item. So how do we express that is the question. Okay, so now you know it cannot be whole numbers. It could either be fractions or percentages. A relative frequency table is when you actually do, if you have the individual frequencies of every item, then you find out what is the relative frequency of one item with respect to the total frequency. That is, say if the total frequency is 20 and the frequency of one value is 3, another value is 4, another value is say 5, and another value is 5, then relative frequencies are 3 by 20, 4 by 20, 5 by 20, and 5 by 20. You take these relative frequencies and you write the distribution. That is a relative frequency distribution. So we know that this 3 by 20, 4 by 20 are all fractions. The question is whether we go for the percentage or we keep it as the original fraction itself. So if you do this 3 by 20 into 100, it will become a percentage. So we don't go for the percentage. We keep it as fractions itself in a relative frequency distribution. And we write that using decimals. We just don't write it as 5 by 20. We just do the calculations and we write the fractions in a decimal way. 5 by 20 is 1 by 4, that is 0.25, right? We write it like that. That is your relative frequency distribution. It is just theory. Don't have to apply this to do any problems. That is why I'm not explaining anything other than this. This question is asked, the answer is fractions. Now you can rush because there's a bit of repetition till some 5-6 questions. So which of the measures given here are based on every item of the series? I already explained this. You can just tell me the answer. Yes, I'm getting the answers. Yes, everyone is right. B, standard deviation, because we find out the mean deviation of every item, we square it, we take the root. So that is the only, sorry, that is the only dispersion measure which takes into account every item. Range only takes the first and the last value. What is this quartile deviation? When we use standard deviation with mean, the mean and standard deviation is used only when your data is normally distributed. If your data is skewed, as I told you earlier, it could be a positively skewed data or a negatively skewed data where it does not follow the normal distribution. We'll explain a normal distribution towards the end. I'll tell you about skewness also then. If that is the case, then we use a median as the measure of central tendency, and you need something else as a measure of dispersion. So that measure is called interquartile range. So what we do with a median is we arrange the data in ascending order and we divide that into 4 quadrants, say Q1, Q2, Q3, and Q4, or like that, 4 quadrants, and we mark the end of each quadrant with these values. So at the end of the first quadrant will be your Q1, that is 0 to 25th percentile. I am telling 25th percentile because it's easy to understand. Just imagine that the whole data set is divided into 100 equal points. That is 100th percentile. All of you will be very much familiar with percentile because entrance scores are calculated in percentiles. Right. So divided 100 equal points, then we get the 25th percentile, 50th percentile, 75th percentile. The 25th percentile is your Q1, the 50th percentile is your Q2, and 75th percentile is your Q3. So Q2 is also your median because it lies at the 50th percentile, which is the midpoint of the data. Clear? So now you have this quartiles here. If you calculate the deviations of any 2 quartiles, you can call it a quartile deviation. Specifically, we take the interquartile range as Q3 minus Q1. That is your 75th percentile minus your 25th percentile. Okay. So one question that will be asked like that is one question that can be asked is what is interquartile range? Q3 minus Q1, Q3 minus Q1 by 2, like that. So the quartile deviation is actually semi-interquartile deviation. That is, it is Q3 minus Q1 by 2. Interquartile range is actually Q3 minus Q1. Okay, so quartile deviation is also called semi-interquartile range. So because it is half of the value of interquartile range. Just need to know this much. Okay. There will be some problems also with median. That is, they can ask you about, say, if they can give some values and ask you to calculate median. So always remember to arrange that in ascending order. Okay, go for calculation of median only after that. Only in a data in an arranged or descending order, median has got any sense. And also the quartile deviation, when you take the interquartile range or something, always remember that that is a difference between the actual values in those positions. And another question can be how much data lies in your interquartile range. That is, when we do Q3 minus Q1, what percentage of data is there inside that? What is the answer? 50. Yes, you are right. When we take the median, you have 50% of data on one side and 50% on other side. When we write Q1, it divides the first 50% into 25 and 25. That is, I'm talking about the number of observations. Your median divides the total number of observations into exactly 2. That is, it is the midpoint of your data. So you will have half of observations in front of the median, half after the median. Q1 will divide the front of the median 50% again into 2. That is 25, 25. Q3 will divide that into 25, 25. Okay, so between Q3 and Q1, you will have 50% of your data. Okay, so you can move on to the next question. The process of arranging data into rows and columns is called. This is a straight question, but I have got students who have got this wrong. There is always a tendency to go wrong on very easy questions because you take it for granted. Never do that. Read the question very carefully and then answer the question. Again, repeat. Read every word in the question. If one word changes, the answer can change. Yes. Tabulation. You are right. Tabulation is the answer. There are no other answers. So, in a frequency distribution, the last cumulative frequency is 500. So, third quartile must lie in. Bracket is there for no other purpose. Ignore the bracket. Just read it. Third quartile must lie in which item? It is what is the position of Q3? It's a simple question. We already discussed this. Yes, 375th item. You are right. Yes. A bit of mathematics, but nothing to write. You can just calculate this in your mind. In a week, the prices of bag of rice were 350, 280, 340, 290, 320, 310, 300. The range is? Yes. I'm getting answers. Yes, you are right. 70. So when you calculate, arrange the data in ascending order, take the first value, that is the lowest value, which is called L, and say the highest value, which is often denoted by S. Okay, so the range is the difference between these two. That is 70. This we have 280 and 350 here. So your range is 350 minus 280, that is 70. Okay, this is a trickier one. I only put this question because you will be surprised. Majority get this wrong. I don't know why. I'm giving you a bit of time because I am getting all the answers. Okay, let everyone answer. Can wait a bit. Yeah, I got so many answers. It's interesting actually. So what are the basic things when we round off? The basic things when we round off are studied in our school itself. It is 0.5 or above, we round off to the next whole number. If it is less than 0.5, we round off to the whole number that is already given without the decimals. That is 143.5 will be rounded off to 144, but 143.49 will be rounded off to 143. That part is clear. But here the problem is 143.95 is 143.95, rounding off it is 144. But you have two 144s in answer. 144.0 and 144. So what is the answer? Is it B? Is it D? So now some people are again saying BB. I got so many D's to start with. Yes, some people are saying D also now. Okay. So if you have sub G is the most appropriate answer. So they are already there. They're telling us one decimal place in the question itself. So if it is asked one decimal place, it's always good to include one decimal place in the answer. If that can be more specific. So the 144 that is given here in the D position could also be 144.4. It could be anything from 143.5 to 144.499. Right. But 143.0 or 144.0 are all having higher specificities than 144. So 144.0 is much more specific than 144 as an answer to this question. Because 144 can be 144.4. 144.4 could be rounded off to 144. But if the question was actually 144.4, then also the answer would have been 144. Right. But the 143.95 is rounded off nearest to 144.0. So your answer is B. Okay. So this is your question on geometric mean. Given n values in a series, the geometric mean is. Read the question very carefully and answer. If you don't know what geometric mean is, just wait, I will tell you. If you already know, have an idea, answer the question. Yes, as I expected, I am getting the same answers again. Yes, many people are answering D. D is the right answer. Somebody has answered square root, and I tell you, you are not wrong the way you were taught, because always we teach geometric mean using A and B, and we tell them the geometric mean is root of AB versus square root of AB. That is how in schools you are taught about geometric mean. There is every chance that you actually answer B for that question. But geometric mean can be applicable to n number of values. It could be any number of values, say 5 or 6 or 7 or 8. So any number of value that you actually take, If you're taking 2 values, it's a square root. If you're taking 3 values, it is a cube root. If you are taking n values, it's nth root. You simply multiply all the numbers. If you are say 10 numbers, just do if the numbers are n1, n2, and if you say x1, x2, as we usually take the variable, is x1 into x2 into x3 into x4 like that up to x10. Your n equal to 10, so you take the 10th root. So geometric mean is nth root of the product of values. So n represents your sample size always. That is why n is used here. So you have, but in this question specifically, they are asking you have n values. So straight away it is the nth root of the product of the values. Okay, this is easier one, but you can go wrong. Some students go wrong in this only because they jump into the answer. Statistics which is not measurable is called. Pay attention to every word in the question. The question is which is not measurable. Okay, I've got A, B, C, and D in the answer. So I think I should explain this question a bit. Okay, so what is measurable and what is not measurable? Anything quantitative is measurable. Okay, and a statistic, or say in statistics, a statistic is the measurement you make in a sample. That is, I want to estimate the hemoglobin values of 100 students in a class. I take a sample of 20 students by using sampling techniques and sample size calculation and all. I got my sample size as 20. So I estimate the hemoglobin values in this 20 students. This is my sample. My n is 20. And I got the value as 11.5. That 11.5 is called the sample statistic. We use the sample statistic to actually find out the population parameter. So the mean hemoglobin value of the population that I am trying to find out using this sample, that original value of the population, the true value of the population is referred to as the parameter, the population parameter. So remember it as SS and PP, sample, statistic, and population parameter. Okay, so now we know the sample statistic is something quantitative because I am measuring that. Population parameter is also something quantitative because I am estimating that also. And I'm saying it can be quantitative. So if it is quantitative, it is measurable. Okay, what is a variable? A variable is anything which varies. Your height is a variable, the weight is a variable, like that. Yes, Rukmani Gopal, I am coming to the answer. Wait a bit more. I am explaining another choice in the same question. Okay, so variable is anything that varies, right? Your height is a variable. So height is also a quantitative value, right? So height can be measured. So a variable can be measured if it is quantitative. So parameter is not the answer. A variable is not the answer. Okay. Then what is the constant? What is this constant? A constant you often come across in many statistical analysis and all. When you do regression or something, always you have a constant there. You remember the constant in your y equal to mx plus c also, right? The c is the constant there. It will be mostly a numerical value. Not mostly, always a numerical value. It is expression. If it is numeric is a number, then it is measurable. You can actually, if when you write y equal to mx plus c, the basic equation itself, you can actually measure the value of that constant. So that is also not the answer. Now only one left, an attribute. So attribute is the name given to such qualities which you capture using a qualitative variable. When you say hair color, gray hair color or red hair color, that is an attribute. Gender is an attribute, male or female. So the most appropriate answer in this is attribute. Clear? Yes. Ramya Mohan, Rukmani Gopal, is it clear? Yes. So we move on to the next one. Okay. You might sometimes be asked such questions to calculate. When you are asked such questions to calculate, because this problem is because you're having an online exam, they can ask you very big questions. I have put some questions like that towards the end. Earlier, when it was like in paper, because they needed too many pages to print, they avoided very big questions. Now, because it comes on the screen, it's very easy to ask such big questions also. Okay, so, but when they ask you big questions, it will be easy to solve. You won't need a calculator. You won't have to write or say calculate it. Usually, if it is a good question, usually you don't have to write and calculate or think and calculate. You can just think and calculate because the numbers will be easily cancelling each other and all. And the choices will also be far apart. So if you have a rough estimation about what is given, you can reach the answer. So pay attention to every single word in the question. The average monthly production of a factory for the first 8 months is 2,500 units. And for the next 4 months, production was 1,200 units. The average monthly production of the year will be. Yes, I'm getting A and D as answers from the students. And A and D are the usual answers also given by most of the students. They get D because they go wrong somewhere. So where do they go wrong? How do you do this question? 2,500 is the average monthly production. That is the first place where people go wrong. That is, it means on average 2,500 units are produced every month. So total production for the 8 months is 20,000 units. 2,500 into 8. See, if it 2,500 into 8, it only requires a mental calculation. But if you are not very strong in your mental calculations, write and calculate. There is nothing wrong in that. Because different people have different abilities. Some people can do all this in their heads. Some people will not be able to visualize this when they are reading this, but they will be very good at doing this using a pen and paper. Or say, you can use your pencil and paper. You have a book or something like that to scribble on, right? Space and all. So you can actually use that space. If a space is not given, there is no space for your rough calculations, there is no booklets, like anything like that. Say, for example, some of the NEET exams are like that. So everything is on the screen and you have no space to do any calculation. In that case, you can be sure they will only ask you such questions which do not require such calculations. So don't worry. Okay, so just 2,500 into 8 is 20,000. And for the next 4 months, production was 1,200 units. So now the doubt is 1,200 for the total 4 months or each month? So if that doubt is there, you can do both and see what are the choices. One will not be in the choice in that case. If both are in the choices, then you specifically look for your English skills. There is a comma after 4 months, which means the sentence has not been completed. So whatever is given in the initial part applies to that also. So it is units per month. So ideally, they should have given you production average monthly production was 1,000 units, but they skipped those two words, but they put a comma there. So that is one way you can justify the question. You can also argue that even if you put a comma, the meaning will still be 100 and all. So then you do that also and see whether that comes in the answer. Okay. Now we can take 4,800. The total production will come as 24,800 by 12. That will be a little bit about 2,000. There is only one choice anyway near to that 2,000. Even if you put it as 1,200, answer will come to something like 1,700 units. That is also not in the choice. So now you can be sure and go with A. Okay, this is a very interesting question. Very easy to solve also, but sometimes a bit difficult to imagine. Usually people get it right, some get it wrong. The mean of 10 observations is 10. All observations are increased by 10%. The mean of the increased observation shall be Shruti Yasna, you need me to explain the last question once more. Shruti, can you hear me? Yes, okay. So in this question, Shruti, what they have asked is, what is the average monthly production of the year? So to calculate the average monthly production of the year, what do we need? We need the total number of units produced in the year divided by 12. Average monthly is 12, that you know, because there are 12 months in an year. So now we need to find out total number of units produced in that year. So we know that production was different for the first 8 months and the next 4 months. In the first 8 months, they produced 2,500 per month. So that will be 2,500 into 8. That is 20,000 units. For the next 4 months, they produced 1,000 units per month. That will be 4,800 units. So total number of units produced in that year is 20,000 plus 4,800, that is 24,800. Now for finding out the average monthly production, 24,800 by 12, that is 2066.55 units. Is it okay, Shruti? Or if it is any specific part that you... Okay, yes. So coming to this question, I got answers as 11 and 100. Okay, so we can use different techniques to solve this actually. Basically, because mean is very sensitive and mean is a numerical value and mean is applied on a data which is normally distributed and all, it's easily you can say that the mean will also be increased by 10% when all the observations are increased by 10%. If you go by that, the 10% of 10 is 1. So mean increasing by 10% will give you 11. If you can visualize that, then it's easy. The answer is 11. Now, if you can't visualize that, what do? You can actually write 10 observations and you can increase every observation by 10%. You can find out the mean and see how much it has increased. Say, one easy set which will give you the mean as 10 is 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, right? Right, 6. So 10 numbers that will give you mean as 10. Just from starting from 5 to say this side of 10, that side of 10, you can write 10 numbers, increase everything by 10%. So 5 will become 5.5, 6 will become 6.6. Like that, you can add everything and see. The mean will come to 11. So another easier method that you can apply. So this is something that you should employ in your entrance exams. That is, when you want to visualize, you use some tricks like this. That is, you are being asked, mean of 10 observations is 10. Just imagine, why can't those all 10 numbers be 10 itself? Then also the mean will be 10. So just imagine there are 10 tens. And every 10 is being increased by 10%. So every 10 will now become 11. Now we have 10 11s. What is the mean? 11 plus 11 plus 11, 10 times will give you 110 by 10. That is 11. That is one way of easy. That is speculations, or say when you do that, you can choose for such tricks and techniques. If you think as 5, 6, 7, 8, 9, 10 and all, 5.5, 6.6, 7.7, 8.8, yeah, it will take a lot of time and effort to find mean like that. Then just imagine all numbers are 10, then also mean will be 10. Because this is, they are saying it as a rule, no? So it's applied to any data. Fine. So we move on to the next question. This is a question on weighted average. That was there in one of the choices. Weighted average. What is weighted average? We will see with this question. So first of all, I want to take a caveat or say an anticipatory bail saying that this question is set outside India. In India, children or child labor is illegal. So this question is in some African countries, but it is still not illegal. It's a contractor who employs 20 male, 15 female, and 5 children in the factory. Male wages are 10 per day, female rupees 8 per day. That is some gender bias. And children, that is illegal, is rupees 3 per day. The weighted average of wages paid per day will be. How do you calculate this? This can be asked because the weighted average, when they ask you weighted average, it will be easy to calculate also. This question is also very easy to calculate if you know the idea. And this can be using in your head, and you will easily reach an answer also. So without using your pen and paper. Yes, I got an answer B from Atira, and Atira is right. Okay, so how do you do this? This is simply, for any average, you need a numerator and denominator. Denominator is always n. That is the number of observations or number of individuals and all. In this case, it is 20 plus 15 plus 5. That is 40. 35 plus 5, 40. What is the numerator? Numerator is the total wages paid, because they are asking about the weighted average of wages paid per day. So total wages paid by total number of workers gives you the average pay. It is called weighted average because we have got 3 groups and 3 groups are not paid uniformly. So what is the salary paid to males? It is 20 into 10, 200. Paid to females, 15 into 8, that is 120. Children, 5 into 3, 50. So 200 plus 120, 320 plus 15, 335. Total salary paid. Now just take the average. You have given the weightage for different groups in different ways because salary is given differently. So 20 males have got a weightage of 10, that is above 8, right? So it is not same. So they are given a higher pay that is being accounted in that. So 20 into 10, 15 into 8, and 5 into 3. 335 by 40. Now you know what 360 by 40 is 9. 320 by 40 is 8. So no need for further calculation. There is only one value between that, 8.37. Yes, ST38, exactly. Okay, this is an easier one. Just a recollection thing. What is the median? This question is there to actually as a break for you to relax. Yes, you are right. This is the easiest question, right? Okay, now it is going to get a bit difficult. Don't worry. The mean is 4 and the distribution is 2, 3, 4, 5, 6. Square deviations from the mean will be. Yeah, tell me. We discussed this already. You know how to do this now, but don't make a mistake while doing it. After calculating everything, don't go wrong by taking, say, 8 plus 2 as 12. Don't make such mistakes. That is totally inexcusable and unpardonable. Because you are going to write a very competitive exam where such mistakes cannot occur. If you don't know the answer, it is justified. But making simple adding mistakes and all is not at all justified. So pay your full attention to what you are doing. Some students answered 0. I request those students to read the question carefully and not to miss a single word in the question. Don't answer any question in MCQ exam with the hangover of a previous question. Nobody will repeat the question in the same exam or say in the same explanatory classes like this also. Yes, you understood where you went wrong, right? Those who answered wrongly have now given the right answer. So this is a perfect example of how you can get something you know wrong. Okay, so don't repeat this mistake. This should be the last time you are making this mistake. Never again. Yes, now everybody is having the right answer. So this is your involvement or say commitment you need to give to the exam. You have to be totally committed to that question when you are reading that. Pay attention to every word. Okay, just think that those are the words told to you by your boyfriend or your girlfriend. You would never miss a word, right? Even you make big say quarrels and of heights on a single word set. Approach the MCQ exam in that mindset. Well, you love the exam. Think of the exam, say, as your boyfriend or girlfriend, and listen to every word in the question, and you think a lot on it, then answer. You won't go wrong. Okay. And also to study like this, you have to fall in love with the exam. Okay, so you are right. No need to explain, right? You have the mean deviation and now just squared deviations from the mean. That is your asking you about the mean square deviation. So the mean square deviation, standard deviation will be the root of this thing. That is the root of 10 will be your standard deviation for this question. Fine. So what is the square of standard deviation called? Sometimes asked, it's called a variance. V-A-R-I-A-N-C-E. Variance is square of standard deviation. So actually in this question, 10 is the variance of this data. Okay, question 21. We are entering another segment. Which among the following is the best sampling method? We have a lot more to complete. We're running short on time also. Yes, so tell me, which is among the following is the best sampling method? Okay, so all of you are going with D. I will give you a clue. D is not the right answer. Yes, few students have answered B. Now the probability sampling, non-probability sampling. Probability sampling, you have simple random sampling, systematic random sampling, stratified random sampling, cluster random sampling, and multi-stage random sampling. These are the 5 probability sampling techniques. Non-probability sampling, you have the convenience sampling, judgment sampling, quota sampling, snowball sampling, consecutive sampling, as you do in the OPs. Take all the consecutive patients coming to the OP and all. Okay, so this is the basic division of sampling. So in this question, among probability sampling, the best method is actually stratified random sampling. So many students actually confuse stratified random with systematic random, and they go wrong on this question. So stratified random sampling is the best method. The next best should be simple random sampling. Because in stratified random sampling, you make sure that every strata in the population is included, and randomness is also there. Simple random, you just simply randomly select the required number of subjects from a data. It is not that easy, because if you are doing a simple random sampling in Trivandrum, your initial participant will be from Neyatingara, and the second participant will be from the other end of Trivandrum, maybe say near to Chengota and in Tamil Nadu border. Can be scattered like that. So don't go for a simple random sampling for your thesis and all when you qualify and do your PhD, because the thing is simple random sampling will not be that feasible. And we'll explain this through the next question. Which of the following is not a probability sampling method? You already told you the answer. The answer is C, right? Simple random, stratified random, and systematic random are all probability-based techniques. Quota sampling is non-probability sampling. Which of the following is similar to stratified random sampling except for randomness? So stratified random sampling, we usually divide the data into strata, and then we take the required number from each stratum in a random way. So the equivalent for that in a non-random sampling is a quota sampling. Quota sampling, an excellent example of quota sampling is your exit polls. There you have different groups of people in the population, and you need representation from each group. So what they do is they identify these groups, and we take say 20, 30 from each group. They only take those numbers to fill their quota, but they don't take those people randomly, but they take them conveniently or judgmentally or say purposively and all, which are all non-probability methods. Okay, convenience sampling is when you take the sampling according to your convenience. This is non-probability method. Consecutive sampling you do in your OPs when you take the next patient out. Snowball sampling we will explain. Another question. So, which of the following can be done if the list of entire units are not available? This is what I said I will explain in this question. Do you know the answer? The list of entire units is called sampling frame. So simple random, you take randomly from the sampling frame. If the sampling frame has say 10,000 names and all, you need your sample is 800. You take this 800 randomly from the sampling frame. Using random number generator techniques, your Excel random number generators or random number tables and all. You identify which all numbers, and then you select the data in those numbers. That is, if you want to select 20 random people from say 100 people, you select 20 random numbers between 1 and 100. Then you select the data pertaining to those numbers. So this could be your serial numbers. So if you get as 25, 37 and all, you take the data at those numbers. 25th person, 37th person, they will be the individuals in your sample, like that. Systematic random is when you actually find out a value called K, which is called the sampling interval. So in the same case, you want say 10 people out of 100 people, you are going to do systematic random sampling. What you do is you find the sampling interval K as 100 by 10. That is total number of individuals divided by number of individuals required in the sample. Then you get K as 10. Then you select one number randomly between 0 and 10 because 10 is your K. Say you get 4, then you take 4, then you add K to that again and again. That is your sample will be 4 of 14, 24, 34 like that. For all these you need sampling frame. But for a cluster sampling, you don't require a sampling frame. Cluster sampling, say if you have say 100 hospitals and you want to recruit some 100 patients from these hospitals, or say 1,000 patients from these hospitals, you decide you are going to take 10 patients per hospital. So initially, you only require the list of hospitals and you randomly select say some 20, 30 hospitals from that. Then you take some 30 patients from those selected 30 hospitals. If it is not adequate, you select 35 from those 30 hospitals. You get 1,000. So that is stratified random. So there, the initial step, you only require the number of hospitals. Then you, from those selected hospitals only, you require the total number of patients. You don't need to have the total number of patients in all the hospitals you start with. That is, sampling frame is not required in a cluster sample. This is the last question that was left for in sampling. That is, which of the following sampling methods would be feasible? For a study in sex workers. Yes, what is your answer? Yes, somebody has given me the right answer. This is snowball sampling. So multi-stage random we cannot do. We cannot do any probability sampling here because it's a very sensitive issue. You can also use the same techniques. You can, like sex workers, if the study is on say drug addicts, then same problem. Because it's a tabooed or highly sensitive area, we cannot go with the probability thing and all that. If we go for a quota sampling, then also we are not able to do this because we won't get such people easily. Or say out in the open for election. Systematic random, we can't. Then only thing left is D and E, snowball sampling, convenience sampling. Convenience sampling also, we take them according to our convenience, but in our convenience, it's very difficult to find people. We can't find drug addict easily. So what we do is we go for something called snowball sampling. It's a non-probability sampling technique. Do you know how snowballs are formed? There will be a bit of snow at the top that will start rolling down. As it rolls down and down, it becomes bigger and bigger and bigger. As it reaches the valley, it will be a huge snowball. Like that, we start with one whom we know or somehow we have got a contact of. So then we go to that person, we discuss with that person, we gain the trust of that person, and slowly and eventually that person will give us one or two more names. Then we go to them, we recruit them, same step. We gain their trust and move forward. And like that, we move forward and finally we end up with some say 25, 30 people. That is a snowball sampling. Now the questions are going to get tougher. Don't worry, I will explain. I might require some time for every question depending on whether students understand that or not. I will move forward only after you get what I am trying to explain. Otherwise, you won't get the full benefit out of this. So these kind of questions can be asked because anything, if it can display on my screen, it can be on your screen also. That is the problem with this new kind of exams. It's actually very simple also, but we need to know a lot of things to answer this. And question is that there was a small town on December 31st, 2013. There were 2,000 cases of diabetes mellitus. And of this, 324 were diagnosed cases of diabetic retinopathy. 2014, 37 cases developed diabetic retinopathy, and 3 of them expired due to myocardial infarction. 47 among them who did not develop diabetic retinopathy also died in the year 2014 due to various cases. 100 new cases each of diabetes mellitus were diagnosed in the years 2013 and 2014. Assuming there were no immigrations or immigrations, the point prevalence of diabetic retinopathy on December 31st, 2014 can be calculated if we also know which of the following parameters. The problem is this: they are not asking you to calculate anything that you have already done in undergraduate classes. They will ask you to do some calculations, the birth, the death, vital statistics and all. Here it is a bit difficult because they're asking you for an idea. What more do you require to actually calculate the prevalence of diabetic retinopathy on December 31st? Choice is point prevalence of diabetes mellitus on December 31st, 2014, the median population of this town in 2014, incidence density of diabetes mellitus in 2014, total number of births and deaths in 2014, none of the above. So this is actually the difficult set of that is the kind of community medicine questions that you will find in the difficult set. Even if you go wrong, no problem, I'll explain the answer. But this question is there to give you an idea about how to think about such questions. And the clue is always stick to your basics, do what you know. If it is a ratio or a proportion, think of the numerator, think of denominator. See if you have the denominator, what you need in the numerator. If you have the numerator, think what you need in the denominator. Yes, as I expected, all of you are going with B. What will you do with B? You have the median population. Now what? So I'll give you a clue. How do you calculate the prevalence of diabetic retinopathy? They have asked for the point prevalence of diabetic retinopathy on December 31st, 2014. How do you calculate that? What is the numerator? Numerator is number of diabetic retinopathy cases on that day divided by what is the denominator? Denominator is the total population on that particular day. That is December 31st, 2014. If you get these two, you can calculate the answer. So they are asking you, what more do you need? Calculate this. Number of diabetic retinopathy you have, right? They are straight away told you these many cases are there. So now what more do you need? You need the denominator, that is the population on December 31st, 2014. How do you calculate that? That is the catch and that is the key here. Okay, I'm getting all the answers. So tell you, the median population of this town in 2014, if you get that, you can easily calculate the population on December 31st if you have the growth rate or the death rate or the birth rate given. That is not given. So if you have the median population, you can only sit with the median population. You will not get the population on December 31st. So we are ruling out B because growth rate or is not given. The death rate or the birth rate or growth rate, nothing is given. Fine. Incidence density of diabetes mellitus in 2014. If we know that will be of any use, the denominator there is actually person time, because incidence density is a rate. For a rate, the denominator is in person time units, but we have no idea about the different of follow-up times of this every individual here. So that is also of no use. What if we get the total number of birth standards in 2014? If we get the total number of birth standards in 2014, we can calculate the growth rate, but we cannot calculate the population on December 31st, 2014, because they have not given us the population in 2013 also. If they had given us the population 2013, then because they have given the number of birth standards, if D is being given, we can calculate the population at the end of December 2014 also. But that is also not given. Can be none of the above. For none of the above, we have to see whether A is applicable or not. What is A here? Point prevalence of diabetes mellitus on December 31st, 2014. What can be done if we get that? Anyone can type the answer if you know. There are some people who have answered A. Yes, Roshni, you can type the answer. Just in short, no need to write big answers. Just type in the idea. Many have changed the answers also after giving A and B and all. Okay, so I will tell you. Point prevalence of diabetes mellitus, if it is given, what is the formula for point prevalence of diabetes mellitus? It is exactly, Roshni has answered the question. Roshni, very good. This is a tough question. So point prevalence of diabetes mellitus can be, the formula is number of diabetes mellitus patients on December 31st, 2014 divided by total population on December 31st, 2014, because it is a point prevalence. Right. If we get that, that can be used to calculate. If we get the denominator for what we want, we have the retinopathy numbers already. And because we have know the diabetes mellitus patients numbers also, if we get the point prevalence, we can calculate the population and use that denominator in the retinopathy part and find out the retinopathy point prevalence. Right. So when we look at this question, A will initially look like a joke. But actually that is the answer. Exactly. Now your answer. Now you get the idea, right? So always look out for these kind of questions. So for this kind of questions, you need to be really well versed with the numerators and denominators of different rates and ratios and proportions. If you don't know that, you are totally lost. If you know those, you can use those to work around these questions. You can see, if I get this, I will get that. If I get that, I will get this. Sometimes you will be given infant mortality rate, and then you will be asked to find out some other rates and all. So the key will be the infant mortality rate. The denominator is live births. There will be some other rates having live births in the numerator maybe. So if you get this value from this, you can use that in the other way and find out that value. There will be, so you will be initially thinking, what has this got to do with that? Okay. So always pay full attention to what is your numerator, what is your denominator, and see what we have, what we need to get. Is it clear? Did you enjoy this question? Okay. So we are moving on to the next one. Aha, hope it won't come in the exam. Actually, these kind of questions come in the exam because you have some 10 to 20% of difficult questions. And that is those difficult 20 questions or 10 plus 20% questions that determine your rank actually. Because there are so many repeaters and all, many people write the easy ones now. They don't miss the easy ones easily now. These difficult questions is what decides your rank basically. So you for answering difficult questions, you have to be very well versed with the subject. That is how MCQs, good MCQs actually extract every idea from your brain. So this question, to think on this, you need to know about all these things. All the choices you need to know. Then only this all the 5 choices will be really good in a very good question paper. If you go wrong in 3 different ways, those will be your A, B, and C. Okay, so whichever way you go wrong, you end up with an answer in the choices. So you think it might be right because it is there in the choice. Okay, so be very careful while answering the questions. Pay full attention. Even if you read it one more time, it is okay. Okay, we move on to the next question. So answer, I have actually written the explanation for this in case you need, for people who don't understand. Okay, you can just read it if you are, say, a visual learner than auditory learner. The point prevalence of diabetic retinopathy on December 31st is the total number of diabetic retinopathy patients, both old and new, divided by the total population of that town on that day. The parameter that we need is population of the town on that day. Option is not directly given the choices, so we should see which option can give us the population of that town with the data available. Thus, if we know the point prevalence of diabetes mellitus on that day, we can calculate the population of that town because we know the total number of diabetic patients from the question itself. Choice B would give us the median population, but we do not get the population on December 31st, 2014. As the growth rate or the numerator does so, number of Sanders have not been given. Choice C would give us the incident density, which is in terms of person years, and we cannot assume that follow-up periods of individuals were equal, so we cannot be sure. Choice D would give us the total number of birth standards in 2014, but we don't know the population of 2013 itself, and therefore we cannot estimate the population of 2014. I think it is clear to all of you now. Move on to the next one. Yes, this also belongs to the difficult category. In a population where the prevalence of hepatitis B was 4%, a new screening test was performed to detect the cases as first round of a research project. Screening test had a sensitivity of 99%, specificity of 77%. The same test was later used in high-risk group for identifying the cases as a second round of the same research project. Prevalence of hepatitis B in this high-risk group was 29%. Which of the following statement is true? To answer this question, you need to know what is sensitivity, what is specificity, what is positive predictive value, what is negative predictive value, what is the likelihood ratio. Only if you know all these things, you can answer this question. Yes, you are answering B. Okay, give that to you. B is the right answer. It's very simple, actually. Sensitivity and specificity, you already know what it is, right? Do you need me to explain that? Do you want me to explain sensitivity and specificity? Okay. Just keep this in mind. This is your 2x2 table. Just keep this table in mind. You have the disease plus disease minus. Again, with the terms of disease plus and minus, I'm using sick and healthy. The explanation can be easy. So disease plus is sick, disease minus is healthy. We do the test in both these groups, have the test positive and test negative. So sensitivity is How sensitive is your test to pick up the disease? That is, among the group of people who have the disease, that is, which column here? The first column, the sick column. Those are the people with the disease plus. That is true positive and false positive. Usually you have A, B, C, and D also. Okay. So this is your A, as we usually use. Maybe. Okay, let's say A, B here. We have the small a, big A, and all. Usually we use the small a. Okay, and this is your B. Sometimes it comes with A, B, C, and D. And this is your C. So A, B, C, D also, don't forget. That is, don't write A in the top and B down. Okay, so this is your A, B, C, D. You always use this also, while sometimes a choice might have this thing, maybe, who knows. So I'm putting, so true positives are given by A, false positives are given by B, false negatives by C, and true negatives by D. So total number of people with the disease, actually A plus C. That is the true positives plus false negatives. Because false negative, because they have the disease, but the test came out as negative. So that is A plus C is the total number of persons with the disease. Sensitivity is, out of this A plus C, how many was picked up by your test as positive? It is how many people with the disease was identified by your test as positive. That is A by A plus C. Okay. So denominator is total number of people with the disease. Out of that, how many was picked up by the test? That is A by A plus C. Or TP by TP plus Fn. That is true positives plus false negatives. So denominator, true positive is a numerator. What is specificity? Specificity is, out of those healthy people do not have the disease, how many did the test tell you that they don't have the disease? That is, they are truly negative. So D by B plus D. D is the numerator and B plus D is the denominator. D by B plus D. True negative divided by true negative plus false positive. That is specificity. Okay. So sensitivity and specificity basically depends on the test. What is this positive predictive value now? A negative predictive value. Positive predictive value is actually, you have a lot of positive results in hand. After you do a test, you get a lot of positive results. If you take all the positive results, what percentage of that positive results are people with the disease or are true positive? That is, look at the row. Numerator will be true positives divided by true positive plus false positive. That is total positives in denominator. TP by TP plus FP. This is out of all the positives, how many are truly positive. Like that, NPV also, out of all the negatives, how many are truly negative. Fine. So this positive predictive value, the negative predictive value depends on prevalence of the disease. That is the catch in the question. Coming back to the disease or coming back to the question, specificity would increase in the second round. So what increased here? The prevalence increased from 4% to 29% in the second round. The question is actually, when prevalence is increasing from 4% to 29%, what will increase in the choices? Specificity would increase in the second round. Will it increase? No, because sensitivity and specificity are attributes of the test. They are not depending on the actual prevalence of the disease. Positive predictive value will increase in the second round. Will it increase? Yes, it will increase. because positive value depends on prevalence of the disease. So we'll explain that very simply using very simple logic. Just imagine if you're sitting in your OP and you are sending for a test that is very common. That is for somebody coming with, say, anemia in your lab. Looking at them itself, they are pale. You are sending for hemoglobins and you are actually checking whether it is low or not. You are getting a low hemoglobin result as positive for anemia. The probability of that to be positive, that is, among all the positives, you get all the positives, probability of a result to be true positive is very high, because the prevalence of anemia will be high in that group who have, say, who is having this pale look. Right. But if you are sending for a test that is not so common here, okay, that is very rare. For example, say you are sending for this antibody titer or something for Nipah virus. For everyone with, if you are sending for Nipah, and say you send for 10 people and you got 1 as positive, or say you send for 100 people, you got 3 or 4 positive results. And I am saying about just the titer, not the antigen or antibody, just the antibody titer test. I am saying not the PCR or such tests which are very specific. Just an indicative test which can go wrong or which can give you false positives. In that case, if you get 10 positives, then the probability of those positives to be false positive is very high, because the prevalence of the disease per se is very, very low. Fine. So if a disease is very common, the probability of a positive test to be true positive is very high. That is, the positive predictive value will be high. If the disease is very rare, then the positive predictive value will be very low, because even if you get a positive result, the chance for that is higher. Is that clear? We can look at option C. The sensitivity would increase further in the second round. No, because we already know sensitivity and specificity are attributes of the test. The positive likelihood ratio will increase in the second round. Will it? We can go for E before that. Sensitivity would increase in the second round. No, the sensitivity will not change, because the test is the same. What is the positive likelihood ratio? If we know that also, then we will be sure about B. Positive likelihood ratio is basically what is the likelihood of a test to give a positive result in people with the disease divided by likelihood of a positive result in people without the disease. So here in this case, it will be likelihood of a positive result in people with the disease is what? A by A plus C. What is likelihood of the disease? Likelihood of the test to be positive in people without the disease is B by B plus D. So A by A plus C by B by B plus D. We can rewrite this. What is A by A plus C? We know it is sensitivity divided by what is B by B plus D. We don't know that, but we know what is D by B plus D, which is specificity. So D by B plus D is specificity, then B by B plus D is 1 minus specificity. That is how you arrive at the formula for the positive likelihood ratio, sensitivity by 1 minus specificity. Fine. It's as easy as that. So that is also depending on the sensitivities and specificities, though that is also the property of the test. So now we are sure the answer is B. Okay, it's about 9:30. Should we continue, or do you want me to explain this further? Because all these are difficult, so I might require 10-15 minutes for every question to explain the concepts. There is another question coming up on study designs that will take at least 10 minutes. Then there is another question based upon the test that we use for different scenarios. Quantitative variable, qualitative variable, which test PUs and all. In a research work, the association between serum LDL levels and socioeconomic status was studied. Socioeconomic status was scored as high, medium, and low. The LDL levels were recorded numerically. Null hypothesis was formulated as there is no association between serum LDL levels and socioeconomic status. Which statistical test will you use to disprove this null hypothesis? Okay. So you know what null hypothesis is, right? In every research, we start with null hypothesis. We say that there is no association. And then we disprove that. For that, we have some data. We get some data. We collect some more data if required. Then what? We tabulate the data, say in Excel sheets and all. Then we use some statistical tests to see whether null hypothesis is disproved or not. And which statistical test do we use? We use the test depending on the nature of the study variables. The study variables decide which test we use. So we can see decision rule. This is called decision rule matrix of the statistical test. If both variables are qualitative, that is, we are going to find association between, say, one qualitative variable which is gender and say another qualitative variable, say diabetic status. We are taking the diabetic status as yes or no, then it is a qualitative variable. And gender, two qualitative variables, we go for chi-square. And if both are quantitative variables, example here given as diastolic BP, which is in quantitative terms, and say quantitative variables FBS, then we go for a test called correlation. So correlation is statistical test employed when both the variables are quantitative, that you need to find out the association. It could be parametric and non-parametric depending on whether the variables are normal or non-normal. I'm not going into all that. It's a bit higher advanced epidemiology and stats. When one variable is quantitative and another is qualitative, so for example, say diastolic BP is quantitative variable and the qualitative variable, that is say diabetes mellitus yes or no, and we are asked to find out association with diabetic status and the actual diastolic BP, then one is qualitative, other is quantitative, then what do we do? That is a question. First of all, let me ask you one question. Is diastolic BP a quantitative variable which is continuous or discrete? Is your BP continuous or discrete? Yes, can type in the answer. Yes, usually we take BP as 120 by 80, or we run it as 118 by 80. Don't write decimals. So is it continuous or discrete? It is a continuous variable. It is not discrete because you can have this error. So I told you earlier when we discussed the earth example, the discreteness or the continuous nature of a variable does not depend on our ability to measure that variable, or the instrument we are using that way to measure that variable. Limitation of the instrument is not a deciding factor for the nature of the variable. So BP is like in our body, BP is like a continuous thing. It can take any value. It could be 120.345. But we are using a sphygmomanometer which can only measure 2 mmHg resolution. In ICUs, you have seen a decimal BP, right? Because there it is required. Okay, so the true and nature of the variable has to be taken into account, not the way we are measuring that. The number of children, any way you measure, it can only be a whole number. So that's a truly discrete variable. BP is a continuous variable. So now, continuous variable and a qualitative variable, we have a quantitative and a qualitative variable. We look at the number of groups of the qualitative variable. A qualitative variable is also called a categorical variable. So a categorical variable, we look at now how many categories are there. So diabetes mellitus, you can have two categories like yes or no. You can also have three categories like pre-diabetic, diabetic, and not diabetic and all. So non-diabetic, pre-diabetic, and diabetic in that order. So for a continuous variable, that is a quantitative variable with another qualitative variable. If the qualitative variable has got two groups, then we go for a t-test. If it is more than two groups, we have to go for ANOVA. In this case also, if this quantitative variable is not normally distributed, we have to go for non-parametric test. This t-test, unpaired t, paired t, ANOVA, everything is called a parametric test. Non-parametric test, you might have heard some names, Ann Whitney U test, Haskell-Wallis test, Wilcoxon sign rank test, Wilcoxon rank sum test, Friedman's test, and so many names like that. Those might come in the choices. Those are all non-parametric tests. Those are all used when the quantitative variable is not known. This is the basis. So now we see our situation. We have two variables. Each are the two variables? LDS level, socioeconomic status. LDS level is taken as a numerical quantitative variable. Socioeconomic status is taken as three categories: high, medium, low. So one quantitative, one qualitative. Which test do we use? ANOVA. Yes, somebody has answered that correctly. They have not given us anything about the normality of the distribution. So if it is not given, assume that to be non-normal. Assume that to be normal. If it is non-normal, it will be, they will say non-normal, or you will have Haskell-Wallis test in the choices. And Haskell-Wallis is the non-parametric counterpart of ANOVA. Okay, Ann Whitney U is the non-parametric counterpart of unpaired t-test. When do we use the paired t-test? We use that when we have one group of students or one group of study participants and we are taking two measurements on the same group and we are comparing the before and after values. And non-parametric counterpart of paired t is called Wilcoxon sign rank test. Student t is another name for unpaired t. Okay, this is clear? Yeah, another table that I explained right now. It's also there. Quantitative, qualitative. Quantitative, two groups. We see whether it is normally distributed or not normally distributed. Normally distributed, sample size less than 30. T-test. Two related groups, paired T. Unrelated groups, unpaired T. Sample size is more than 30, there is something called Z test. It is not normally distributed. Then we go for two related groups, then it is Wilcoxon sign rank. Two unrelated, it is Ann Whitney U. If we say more than two groups for the quantitative variable, that is one variable is quantitative. We are talking about the other variable as two groups or more than two groups. It is normally distributed for two groups. We have different groups and one measurement. We go for ANOVA. That is the case in this question. We have different groups, that is high socioeconomic, low socioeconomic, socioeconomic, and there is one measurement. We go for ANOVA. It was same group and more than two measurements. We go for repeated measures ANOVA. It is not normally distributed. Instead of ANOVA, we go for Haskell-Wallis. Same group, more than two measurements. Instead of repeated measures ANOVA, we go for Friedman's test. This is the master table. which test to use. You can maybe remember this, or at least you can remember the other one. Which one? The decision rule. That is this one. This one again, I will run once more. 2 groups, more than 2 groups. That is, the one variable is quantitative. The qualitative lying here is for data, and the data itself is qualitative. That is different. Here we are talking about quantitative variable, qualitative variable. Qualitative data is what we get in interviews and all. Analysis is totally different. That is there because it is a master table. So quantitative data, if we have 2 groups for the qualitative variable, we have normal distribution for the quantitative variable, not normal for the quantitative variable. That is where we use these tests as already explained. It might be a bit difficult for those who haven't revised these things. You can read about this. One question will be there from this. For the qualitative data, I strictly said we can use chi-square if both are qualitative. Only in that case. Other than that, put that there, but that is actually wrong. The data is qualitative. Then we use other techniques for the FGDs, in-depth interviews, and all that used for qualitative data. That might be asked sometimes. How do you do a qualitative study? Then we say we do a qualitative study by focused group discussions, in-depth interviews. We analyze the data using some other techniques and all. Okay, here in this table, you can actually interpret this in this way, that we're talking about when both variables are, when one variable is quantitative and when both variables are qualitative. When both variables are qualitative for a quantitative study, we go for a chi-square. When one variable is quantitative for a study, other is qualitative, we look at the number of groups of the qualitative data and we look at the normality of the quantitative data. That is how we get all these studies, all these tests, statistical tests.